For our next talk, we have Cameron Buckner from the University of Florida.
Thanks for the invitation, and I've enjoyed the workshop a lot. So I'm going to move through a lot of stuff pretty quickly, so I get to the main focus, which is on empathy and modeling empathy better in AI as a way towards more human-like decision making. But I'll go over a bit of the theoretical background, mostly from the book I published last year that applies sort of empiricist philosophy, especially philosophy of mind, as a way to understand recent achievements and chart future progress in deep learning research, especially deep learning based AI. So, as a way to kind of situate the discussion, as everybody knows, AI models can be biased. They're necessarily biased in a kind of mathematical sense, that is, the architectural choices made in designing a model requires some sort of prior assumptions that make the learning of that model more efficient in some environments than others. And that's unavoidable. And in many cases, it's desirable, but there's also ethically problematic notion of bias that many of these models are also vulnerable to because they're trained on human data sets that themselves instantiate a lot of discriminatory and ethically problematic biases. They can reproduce and often even exacerbate those. I take it this is a familiar point to everybody here. And there's two approaches that have been adopted by researchers to try to counter the bias in the decision making of these models. You could call one top down, that is, you try to find some, say, rules, manually programmed rules or algorithmic rankings that if the system follows those rules or uses the rules, then you want to say it's unbiased in some way. And there's a lot of familiar examples of these, but there's also well-known criticisms. They tend not to flexibly generalize very well to situations that the programmers didn't explicitly anticipate. And you might also think that answers in the real world are a lot more context sensitive and variable than a simple set of rules can allow. It's a favorite of sci-fi plots as to, why did the robots go haywire? Because they encountered some kind of conflict between the rules or something the rules didn't anticipate. So the other approach that a lot of people have explored is you might think of a kind of bottom-up strategy where you try to have them learn directly from some kind of problem data how to make decisions effectively, give them some kind of incentive to be more ethical or fair, and hope that everything will work out in the end. But these, methods have also found some successes, but they also tend to be pretty inefficient. You need very large data sets to try to debias them through, say, fine-tuning methods. And they also struggle on method which is out of distribution or has a statistical structure different from the ones that you trained them on in the training sets. And I'm going to sketch a kind of way of making the bottom-up approach a bit more powerful by making the architecture of the systems more complicated. That's inspired in part by empiricist philosophy of mind, especially sentimentalist ethics associated with Hume, Adam Smith, Sophie de Grouchy. And the idea, the motivation behind a lot of my work in linking empiricist philosophy to understanding deep learning is that deep learning has succeeded as well as it has over the last 10 years, because in many cases we've found a kind of architectural inductive bias that's a good fit for the informational structure of the environment that we needed to succeed in. So what we need to do is find, what is the informational structure in the environment that makes ethical problems hard for humans, and then figure out what is the right kind of architecture that'll be the good fit to make these systems very efficient in countering those kinds of problems. Hopefully that'll make more sense by the end. So I'm going to give you a basic frame of nativism versus empiricism and understanding recent progress in deep learning that's explored at great length in my book. And I'm going to talk about some of the rationalist assumptions I think that people have been working under as they try, even in deep learning, to make the systems more ethical. I'm going to argue against them very briefly. I'll talk about a different approach inspired by sentimentalist ethics that I think hasn't been very exploited in this space yet, but I think it's in some sense the most natural way to go, at least if we want the systems to make more human-like decisions in moral space. And I'll talk about some specific research directions that go beyond the book as to what are things I want to work on next. And I hope people will have a lot of suggestions, ways I can do this better. So it's already happening in the computer science. This isn't just a philosopher imposing stuff from the outside. If you look at some of the major deep learning papers, they talk about tabula rasa methods. This is a direct reference to language associated with empiricism all the way back to Aristotle, Aquinas, and Locke. Similarly, the critics of deep learning are happy to paint it as an empiricist method and argue that blank slate approaches are doomed. We've already heard a bit about Gary Marcus in this workshop so far. Some form of this nativist empiricist debate has showed up in every generation and in every discipline ever since, Plato and Aristotle were arguing about the origins of abstract knowledge in humans. I think it's just the same old debate, finding a different incarnation each generation. There's a lot of work. I'm going to skip over this pretty quickly. You can go to my book if you want a little bit more context and see the ways that different people have framed this. But there's a number of places where this frame and some of the most influential secondary literature appraising deep learning's progress shows up from people like Pearl or Brendan Lay, Ullman and Tenenbaum, and so on. The way I like to interpret this application of nativism versus empiricism in the current context is not as this timeless philosophical riddle that gets continually raised every generation, but never really resolved. But the thought is, for the first time in history, we now have some methods to make machines that are powerful enough to let us really arbitrate this debate and treat it like an empirical debate, right? So instead of fighting over things that we don't have control over, the basic structure of the human mind, we can build machines according to nativist principles, and we can build machines according to empiricist principles and just see which ones are more successful or human-like. So the victor go the spoils, right? And you know which side I'm on because the evil robots that go haywire and kill everybody are over here on the nativist side, and the good robots, we could debate Dorothy, but the good robots are over there learning from the data. However, in order to set up this context, we need to be really careful about how we interpret the rules of the game. In particular, I think the nativists and rationalists have tended to paint empiricism as a kind of strawman position that's not very plausible, even to the major historical empiricists. Steven Pinker is maybe one of the worst offenders here. He interprets the blank slate metaphor like literally it's like a slab of stone. And he says, you could throw any amount of data at a slab of stone, it's not going to learn anything. Obviously, that means that's not what all these smart people actually meant to defend all along. Gary Marcus, kind of a Pinker student here, puts a little bit more formal garb on this construal. He says you could think of cognition as a function over four variables, A, R, K, and E, where A is innate algorithms, R is innate representational formats, K is innate knowledge, and E is experience. He says a true blank slate would set K and R to 0 and A to some extremely minimal value and leave the rest to experience. This is what Locke articulated when he said all ideas come from sensation or reflection. Reading this part in Marcus and seeing the kind of press it got in part is what inspired me to write the book, because if you read even the next few pages of Locke, you're struck by how wrong a construal this is of what Locke's actual view was. And I'll say what's missing here very shortly. So in particular, what's missing is faculty psychology. I think all the way back to Aristotle, almost all the major empiricists have been what we would call faculty psychologists today. That is, they were adamant no innate ideas, or what we would say today, innate concepts, should be allowed in. But they had all kinds of ideas about innate cognitive architecture, we might now call it today. So things like memory, imagination, attention, and I'll talk about in particular later, empathy. If you don't believe me, there's a couple nativist philosophers, Lawrence and Margolis, who've written a few articles about this. They agree that this is a much better way to frame the debate, is over whether domain-specific representations are required to get human-like learning off the ground, or whether it can be achieved by a few domain general learning systems being like repeatedly engaged. And that can include stuff like memory, attention, imagination. As the Stanford Encyclopedia of Philosophy entry on Locke ably puts it, while the mind might be a blank slate in regard to its content, it's plain that Locke thinks we're born with a variety of faculties to receive and abilities to manipulate or process the content once we acquire it. Most important here are processes of abstraction, which I talk a lot about in the book and will be important in the moral case. Moral abstraction being, one of the key ways you might reach impartiality in your moral decision making, but also faculties like memory, imagination, and empathy. So this is a kind of standard faculty taxonomy you might find. This is from Peter Millikan, a Hume scholar, where you've got the senses, you've got reflection, memory, imagination. Why is the history of philosophy relevant here to machine learning? The engineers think this question of nativism versus empiricism is really important in deciding what kinds of methods we should adopt for the next iteration of artificial intelligence. In particular, should we manually program a lot of innate knowledge into these systems as the next step, or should we have better learning methods? But this connection is not being drawn in kind of a charitable way. So we should really start with a fair contest if that's indeed what we want to do. And I think the deep learning engineers can continue to mine some gems from the history of philosophy when we set up the contest in the right way, especially as I'll talk about in more detail later for more moral decision making. So the one that we really want to talk about here is empathy. Empathy is kind of a special case amongst the faculties because it looks a little bit domain general. It might be a little bit domain specific. It might be specific to the social domain, but then it's also one that a lot of the major empiricists thought might be constructed out of other faculties, in particular, a combination of imagination, memory, and maybe reflection. I'll talk a little bit more about how that might work later on. Maybe it's kind of like an faculty that's constructed out of several other faculties through more experience. If you want any more detail on any of the basic setup there, read my book. Otherwise, I'm going to move on very quickly from the basic setup and get on to empathy stuff. So the basic question here is, how do we come to have abstract knowledge? Does it come from repeatedly applying these domain general faculties in a more complicated architecture? Or do you need to provide at least some innate moral knowledge or innate domain-specific knowledge to get human-like learning off the ground? Now, I want to draw an analogy between rational decision-making in the moral domain and just human-like perception in the perceptual domain, because you might recall the first major achievement of deep learning that really got everybody's attention was these image labeling and recognition experiments, where you had systems even back in 2014 that were classifying images, very highly complex images, at levels that were sort of at human or superhuman levels of accuracy. And that was an achievement that even experts in artificial intelligence thought, was 20 years down the road. I give some examples in the book of citations from people like Rodney Brooks saying, like, this is the hard part of AI, is mastering all this complexity and seeing the sort of perceptual abstractions in all these, high resolution variations that they can appear in images. Machine learning researchers, when they study this problem, they say it's really difficult because the problem of perceptual recognition is characterized by so-called nuisance variation, right? That is, imagine this is an example lots of people have talked about throughout the ages. Suppose you're trying to recognize chairs in photographs. The thought is there's not like a single canonical chair exemplar model that you could just compare all the other chairs to on some kind of raw similarity and use that to recognize the abstract concept of a chair. They can be rotated, they can be different colors, they can be different positions in the visual field, they can be covered with occlusion, right? Different shading and lighting conditions. These are nuisance parameters that the thought is any perceptual categorization method is going to have to learn how to systematically overcome these sources of nuisance variation that introduce a lot of complexity and variation that is orthogonal to the categorization you're trying to make in the input stream. And the same goes for other modalities, right? In fact, the very same models, the deep convolutional neural networks that work really well for controlling nuisance variation in visual data are also very good at controlling for nuisance variation in auditory data. But even though it's very different in structure, right? So the problem for auditory data would be things like tone, pitch, duration, volume, accent. If you're trying to make a speech-to-text model that could recognize the same phoneme spoken by lots of different speakers, you'd need to learn to control for all those sources of nuisance variation. And I talk a lot in length in the book about how the distinctive architecture of a deep convolutional neural network does exactly the thing I said earlier. It has a kind of perfect fit for the domain general inductive bias that it's really good at recognizing, and the structure of the nuisance variation in the input. And that's why they work so well. I think if you want to understand why deep learning is a big leap over previous methods in AI, that's one of the best places to start, is to really, really understand that well. And I want to already get you thinking a little bit, what about social and moral nuisances, right? So if we have some idea about sources of variation that make perceptual recognition difficult in the real world, what are the sources of variation that make recognizing moral properties or making the right moral decision difficult in the real world? I could say a lot more about this, but I'll kind of move pretty quickly. Glossing over a lot of details, the reason these systems are so efficient is that what deep convolutional neural networks do is they transform the model's sense of perceived similarity amongst exemplars. So if you imagine you had two different categories, say a square and a triangle, they might, in terms of like raw perceptual characteristics, look pretty similar to another on an initial presentation. But what you need to learn to do is kind of stretch and squish and pull space until the sense of perceived similarity is, very high. That is, they're very close to each other in perceived similarity space for all the triangles. And the squares are also very close to one another. But now all the squares and all the triangles have been kind of stretched and squeezed to be far apart from one another. Deep convolutional neural networks are very good at doing that. And there's a good reason to think that the ventral stream in the brain, which is the part of the visual pathway in the brain that does this same kind of abstract feature recognition task and perceptual processing, is applying very similar processes to achieve the similar task. In fact, the basic structure of a deep convolutional neural network back in the 70s was inspired by neuroscience on the cat visual cortex. In particular, there's a kind of interplay between so-called simple cells and complex cells in the ventral stream. One is really good at recognizing features in a particular presentation, and the other one is really good at making the recognition of that feature invariant across lots of different particular presentations. And then the deep convolutional neural network iterates those in many layers, one after the other. And in each stage, the thought is you're getting more abstract feature detection and you're stretching and squishing space to recognize the abstract features you want to see better and better. Okay, so the question is, what kind of architecture would we need to control for the kinds of nuisance variation we find in moral space or social space? This is not a completely alien way of thinking about things, even from sort of rationalist or nativist starting point. If you go to a rationalist or nativist psychologist, and you ask them, what do you really need in terms of innate knowledge to be able to understand, to do social cognition in a human-like way or make moral decisions, they'll often start talking about things like theory of mind, right? Where the idea is you need to be able to understand that other people are also agents like yourself, but they can have beliefs and desires that differ from your own, right? And the difficulty then is you need to control for the kind of conflict between your own beliefs and desires and those of another agent. And, this has been a very influential approach to developmental psychology and even in AI inspired by the relevant developmental psychology. You've probably all heard various versions of the false belief task. This is the Sally Ann task picture here. And there are versions of those that were pursued by DeepMind in this really simple example where they build a kind of theory of mind net to try to attribute beliefs and desires to agents in a simple prediction task. In this case, it's a food trucks task. They've got a little avatar that's moving around looking for a food truck. And there's like, Lebanese food truck and a Korean food truck. And the observer's watching the behavior of the avatar moving around and trying to predict its future movement. And it does it in part by having separate networks that attribute preferences and then attribute current desires. So like if you see the agent go around the corner and see the Lebanese food truck and then backtrack to go to the Korean food truck, you might say, oh, it actually preferred the Chinese food truck and it believed it might be around the corner, but then it saw the Lebanese food truck and it actually prefers Korean to Lebanese, so that it went around. And then you would have more efficient predictions on the next iteration as a basis of that. And it can supposedly pass a false belief version of this task in the food trucks world. Here's a kind of picture I talk about of the architecture of that network in the book. And it is a little bit domain specific, so it's a bit of a concession, I think, to the nativist, and that they build separate subnetworks that are just dedicated for mental state representation and preference representation. Other approaches, if you were drawing from nativist developmental psychology, you might think you need innate representations for things like social agents, persons, maybe faces, distinguishing helpers versus hinderers, false belief understanding. There's a long list here of things that they've appealed to. And the idea here is that humans are supposed to begin as these sort of solipsistic, instrumentally rational egoists, right? Think about how much moral philosophy starts from this standpoint, that the problem is like we've got to somehow talk people out of being solipsistic egoists, right? With argument or whatever. And that's kind of the way that a lot of this rationalist nativist moral philosophy and psychology takes as its starting point, is you're supposed to find some kind of rule or some kind of inference that can help you bridge that self-other gap so that you care about other people and are factoring in their value and interests in the right way. And that's why you need abstract moral rules and maybe theory like social cognition. So the empiricist approach has instead been to emphasize empathy, and I'll gradually circle in on this. I want to say before I do that there is some interest already in machine learning and trying to model empathy in these systems, okay? But I think they're not yet getting what we really need. And I'll say, what that is after I explain what they are doing right now. So in particular, FAIR back in like 2019, I think, they developed this data set called the empathetic dialogues data set. And the idea here is you're supposed to enhance the ability of their chatbots to label emotions in dialogues and then make more appropriate kind of follow-up conversation as a result, right? So here's an example of an interaction. You say, I finally got promoted at work today. And then the model should be able to label that as, oh, that person should feel proud as a result of what they said. And then instead of, saying something a little tone deaf, like, why would anyone promote you? It should say instead, congrats, that's great, and kind of something that's appropriate to the emotion that the speaker should be feeling. There's some more examples of the kind of data that's in this data set. They collected like 20,000, I think, dialogue snippets, and they were mostly crowdsourced. So all the standard worries you have about crowdsourced data apply here. We can talk more about that in the Q&A. But they start with a kind of label as a signal to train on, and then there's a kind of conversation. And what the model's supposed to learn to do is kind of predict the hidden label in the same way it learns to predict everything else. And they get pretty good at doing that. Some examples of the kinds of emotions that this data set trains the model to recognize. And unsurprisingly, it does that on the basis of word use and kind of learns what are the most commonly used speaker words associated with this emotion and what are some good listener words to then produce once you've labeled an interaction as involving that emotion. The things that I worry about here, that it's not really getting at the philosophically interesting role of empathy as the empiricist moral philosophers have seen it, is this mostly construes the role of empathy as kind of solving this emotion labeling problem. It's a very simplistic idea of what empathy is supposed to do here. Okay, fine. We didn't have any good data set here for machine learning until now. You got to start somewhere. And probably the modelers here would even recognize it's just a first step. But that's a very simplistic idea of what empathy is supposed to do here. Moreover, it's developed largely for the purposes of making more human-like and satisfying chatbot experience, rather than, making the chatbot fairer or more understanding or make better moral decisions. Empathy in humans probably also involves other things, especially perspective taking and maybe also motivational aspects like emotional contagion or even just directly valuing the emotional experiences of other agents. It also assumes that each dialogue has a kind of perspective independent gold standard label to fit, which I think is a questionable decision in this case. So you could imagine, suppose the person hates their boss and they hate their job and they're only going to get more work, and you sort of know these things about the person, then you shouldn't conclude that they feel proud as a result of being promoted, right? You should have this kind of flexibility that you can put yourself in the other person's shoes and understand that different people might have different emotional reactions to kind of the same event, right? And also the motivational component of empathy is totally absent. So basically the rest of the talk, I'm just going to be kind of sketching what are my ideas for a sort of philosophically inspired research program to help address some of these challenges, to use a kind of empathy-based approach to make these systems fairer and be making more human-like moral decision-making. Well, if we look at the details of sentimentalist moral philosophy for inspiration, the idea is that moral social cognition starts much earlier in development, from basic mechanisms to respond to the emotional states of others. Hume talks about emotional contagion, right? You see somebody afraid, you get afraid yourself. And a lot of other empiricists start there, but obviously that's only a very, very early first step, and we need to get to something much more sophisticated pretty quickly. Adam Smith is often regarded as having one of the more sophisticated views in this space, and he starts with Hume's empiricist moral psychology and argues that the abstractness characteristic of mature moral cognition in humans is going to be scaffolded from basic sentiments using experiences of being judged by others in childhood, right? So the idea is, you think about if you're a parent, you might find your kid gets angry at certain things and afraid of certain things that you regard as not being well calibrated. You and their peers and their teachers and other caregivers are giving them lots of social feedback about the times that it's appropriate to display certain emotions and when it's inappropriate to display certain emotions. And the thought is this is the starting point, the training signal by which people learn to start calibrating their emotional and social reactions to approach what's more appropriate in their culture. Sarah Songorian, I think, if you're interested in this, is a really great commentator of Smith here, and she also draws a lot of ties to recent trends in moral psychology over the last 10 or 20 years, where there's kind of independent pressures and conflicts that I think is recommending a return to sentimentalism to be reappraised. She argues in particular that Smith's reflective sentimentalist view is the antidote to this kind of dual process malaise that has cropped up in response, especially to the work of like Haidt and Green, where you see there's this more intuition-based approach that's kind of like you've got these gut feelings you need to learn to control and calibrate. And then there's a more reason-based system two type process. And everybody's kind of wondering, is one supposed to dominate the other? Or if you have a two-system view where they're both involved in mature moral decision-making, given that they seem to have different formats, how can the two interact and calibrate one another? And Samborian argues, I think, nicely, based on Adam Smith's work, that if you have the system two kind of grow out of a very gradual social calibration of the affective system one, then the problem of getting them to talk to one another and calibrate one another is going to be much easier. For Smith's view, the idea is that this process of social calibration should eventually terminate in developing what he calls the impartial spectator view, right? Which is the idea is you don't ultimately want to be just deciding what do you think about this particular situation, or what does this other person think about the conflict being considered at the moment, but what would an impartial spectator in my culture, or maybe even transcultural impartial spectator view, think is the right thing to do in this situation that kind of takes into account everyone's values and interests and affects. There's other stuff to look at here. I'll skip over the quotes, but we can come back to, places where Adam Smith said this if anybody wants to get into Smith interpretation. In the book, I talk a lot also about Sophie de Grouchy, who was a translator of Smith and wrote this really nice work called The Letters on Sympathy. It's kind of it goes well beyond just a commentary on Smith. There's some unique views there. And the main departure she has from Smith is she thinks we actually need to take the start much earlier in development to the earliest stages in the crib. And she works out some issues that Smith had about motivation. She has a kind of, we would now call it a reinforcement-based learning theory of how empathy gets off the ground, which she likens to, if you stub your toe, it hurts directly and it's kind of like directly motivational. But she points out even remembering stubbing your toe really badly is kind of like aversive for you, right? There's a kind of secondary motivational force. It's kind of fainter and less immediate, but it's still like you don't like even thinking about or imagining really painful things happening to you. And she thinks this is the kind of motivational hook for empathy to get started and being relevant to your own decision making. And she thinks that process starts from the earliest stages of infancy. In particular, it starts before the infant has even developed a distinction between its own body and the mother or other caregiver's body, right? So this itself is a cognitive achievement that's not really fully played out until 12 months or 18 months of age, where the infant has a model kind of their own body where they can control it fully and distinguishes it from the caregiver's body. And a number of anthropologists and developmental psychologists have interesting work on this. And so the idea is if you're starting to care about what happens to the mother or caregiver through these simple processes of reinforcement learning before you even distinguish yourself as a separate agent from others, then this sort of Rubicon of the self-other gap that so much other moral philosophy has regarded as the biggest problem to solve is sort of dried up before we even have to cross it. And I think that's a really elegant solution. And if you're building reinforcement trained AI agents, you might want to build that solution into them from the beginning in their architecture, as opposed to turning them into solipsistic egoists that don't care about anything else unless they're like bound by this external rule that you tack on at the very end. So I'll skip across this and get to some ideas as to how you might actually build an architecture that could deal with the kind of variation you find in moral and social decision-making problems. So the start is to talk about place cells and the medial temporal lobes. And I don't know how many people are familiar with this story. It's one of the great stories. O'Keefe and co-authors won the Nobel Prize for this work 5 or 6 years ago at this point. But the story was there's this interplay between place cells and grid cells in the medial temporal lobes and between the hippocampus and the entorhinal cortex, where the place cells let you kind of bind particular snapshots of what you see from a particular location. Say you're a rat running in a maze, you might be able to see a bunch of landmarks from a particular location in the maze, and a place cell fires for any one of those particular looks. And then the place cells are connected to so-called grid cells, which just have a kind of periodic firing rate for every so often for kind of like a grid around the environment. And the idea is between the place cells and the grid cells, you have sort of like a Cartesian coordinate system. This is the work that was called the hippocampus as a cognitive map, right? You get this map-like representational structure that between the firing rates of the place cells and the grid cells, you can place on a spatial map of the environment the individual's location wherever they are in the maze. And once you have a flexible representational system like that, you can do all kinds of cool inferential things with it. In particular, if you're a rat running a maze and you know where the goal is on that spatial map and you know where you are on the spatial map, and you learn one of the paths to the goal has been cut off by a barrier, you can reason about, well, what's another way that would get me to the same solution using the combination of place and grid cells. Now, what's really interesting for present purposes is that researchers have recently found that there are place and grid cells not only for spatial position, but for all kinds of other ordinal monotonic magnitudes as well. There seems to be one for sequences, right? What order something occurs in a sequence. There's also ones for various things in feature space, like tartness of fruits. There seems to be place and grid cells. There's even ones for social hierarchies. So they found kind of mapping for soccer IQ, which is a combination between athleticism and your skill in playing soccer. Social hierarchies seem to have place in grid cells. There's even been work done on a variety of different animals. Bats in particular, there was one that showed that there were place and grid cells in bats that seemed to fire adaptively based on the position of the other conspecifics location in the social hierarchy. And so the idea is these cells are wholly domain general flexible in the type of bias that they induce and what they're really good at learning. What they're really good at learning are how to organize a whole bunch of features on monotonic dimensions. The dimensions could be wholly abstract, right? Spatial dimension's a good one, but it could also be temporal dimensions. It could also be social dimensions, right? And now you can start to think of what are the difficult social nuisance parameters that make moral decision-making hard? Well, there's various kinds of, preferences that, I like some people better than others for reasons that we might not think are morally relevant. There's economic complications, right? People differ from one another according to socioeconomic status in a way that can confound moral decision-making, and so on. Many of these problems that make moral decision-making difficult can be understood as problems that could be overcome if we could reason flexibly around distances in social space. There's some other work, this gets a bit technical, but I can come back to it if anybody wants to hear about it, that suggests that transformers, the kind of architecture that's behind large language models today, are able to spontaneously develop place and grid cell representations as a result of the self-attention mechanism. And they have various mathematical results that show there's a kind of equivalence between the computations that the self-attention mechanism performs in transformers and place and grid cell encoding in the hippocampus. This is still pretty early and speculative, but it's quite interesting to me that you can show these kinds of interplays sort of spontaneously develop between representations discovered by the transformers when trained on a spatial reasoning problem. Another piece of the puzzle is there's also now a bunch of studies where they do so-called social artificial rearing. So I'm thinking in particular of Justin Wood's work here at Indiana University. And what he does, he's got a system where he can grow biological chickens, so hatch chickens from the egg, and put them in a virtual reality environment where everything they see is controlled by a computer. They're seeing, basically they're living in a video game from the minute they hatch out of the egg. And then he can compare their behavior in various social situations interacting with these other video avatars with artificial agents that are structured by deep neural networks that are interacting with exactly the same stimuli. So you can completely control for any confounds in the input between the biological chick and the artificial agent driven by a deep neural network type system. And he finds all kinds of social correspondences. For example, there's an effect in newborn chicks where they seem to immediately prefer sort of grouping together in social groups as opposed to avoiding one another. And this was thought by nativists to be evidence for an innate representation of a social agent. And he shows that you can get this clumping effect in completely vanilla deep neural network driven agents that you would say from a God's eye view have no innate representation of a social agent. So this is just to show there's also a way now we could do some social learning experiments. If we were trying to use Adam Smith as inspiration here and we wanted these agents to kind of learn from feedback with one another, all we would have to do is get a bunch of agents and put them in a kind of social artificial controlled rearing study and make sure that their architecture is right so they can pick up on the kind of tuning from one another on what are the appropriate reactions to display to one another in various situations. There's also reinforcement learning from human feedback, which I talked about as another way we could socially tune them in ways that we want. I can come back to that if anybody wants to hear it. So I think there's promising early results here, suggest that AI can be debiased in this way, but we need to add imagination and the sentiments. So these have been part of the empiricist moral philosophy that's so far kind of missing from the picture I've told you so far. So in particular, Adam Smith and Sophie de Grouchy, they think we come to be fairer in our moral decision making by imagining how other people would be affected by the decision that we make, right? And we try to find some kind of decision that harmonizes all of the relevant values and affects that are important to the situation according to the perspective of the impartial observer, right? I think we would need much richer kind of imaginative modules in these systems to really say that we're doing something like what the faculty of empathy is said to do by these empiricist moral philosophers, right? It's not enough just to label an emotion. It's not even just enough to have your tuning of an affective response being affected by other agents in some social simulation. You need to be able to kind of imagine how various situations would affect other agents. And that would just be another kind of architectural innovation. I don't think it's out of bounds of current methods, but I haven't seen anybody doing it directly yet. For what it's worth, we could also, this provides an opportunity to make the methods have some sort of cultural variability, right? So you could, for example, tune different basic affects into the system. So there's some work by Liu, for example, that suggests, if you were making like a caregiving robot for a Japanese elder care home, you might want to tune it towards different affective reactions than if you were making one for, a Western care situation. There's also all these nice ways to leverage social learning that I mentioned, either from other artificial agents or from reinforcement learning from human feedback. There's this nice fit, I hope, between the kinds of representations that transformers develop and the kinds of nuisance variation that we find in social and moral decision making. That's the grid coding story that I mentioned earlier. We would still, though, need imaginative simulation, like I said, and more multi-dimensional feedback than these systems typically receive. So I don't know how many of you have actually played with the reinforcement learning from human feedback systems, but often you'll get a kind of like Likert scale where you say how helpful or harmful the response was, or just a thumbs up or thumbs down. The thought would be that the kind of feedback that we need for sentimentalist inspired tuning would need to be a lot more multidimensional, right? It needs to say like, you could imagine sort of like aesthetically pleasing or not, should be afraid or not, or shameful or not. You could think to tuning them to the particular set of affects you think you want the system to be built with, but it needs to be a lot more complex than just thumbs up or thumbs down. Yeah, and you would hope that this impartial spectator perspective comes from social learning and imaginative simulation as the system interacts with more other agents and gets better tuning from reinforcement learning from human feedback. So the next steps for me, I'm asking myself what I, as a philosopher, can do to help push the AI forward in this perspective. And this is in order of ambition. I think the first thing we could work on is better benchmarks for artificial empathy, and in particular, ones that emphasize differential responding to the same situation based on differences in social position context, right? That's the example of like, well, if you got promoted, but you hate your boss and you hate your job, maybe you don't feel proud about it in the same way that somebody who loves their boss and loves their job. We could also, maybe next more ambitious would be to design better training data sets for AI, maybe with more social nuisance variation in there. Building a new data set is a challenge, but if anybody wants to collaborate on that, let's talk. Even more ambitious would be fine-tuning those models to be more empathetic in this particular sentimentalist moral psychology inspired way, right? Where you're kind of starting with a very flat-footed system that's not very good at empathetic simulation and kind of trying to gradually fine-tune them to be better and better at this kind of inference task. And then finally, more authentically sentimentalist architectures. And I have a lot of ideas there, but no time left. So I'll end there and happy to come back to anything I moved over quickly.
Hey, thanks for that interesting talk. I've recently been thinking about Mengzi, the ancient Chinese philosopher, Mengzi's view of moral development and how it's different from a lot of Western approaches that center the self. And so one of the ways of thinking about empathy and the de Grouchy view kind of is an interesting twist on this, but it sounds like it's kind of in some ways fundamentally similar. You put yourself at the center, and then there is like a next ring out and a next ring out and a next ring out, and the ultimately you come out with something impartial. But Mungza builds his moral developmental psychology on an innate tendency to react to the well-being of others without any reference to yourself, right?
Mhm.
So I don't know how much you know about Mungza, but the kind of most famous example of this is he says, anybody who suddenly saw a child crawling toward a well about to fall in would react with alarm and compassion, right? And it's not because the child is fearful. The child doesn't even know to be fearful. So they're not like taking the child's fear and then experiencing it themselves. It's a direct concern they have for the well-being of others. And then he builds his moral developmental idea on extending that appropriately based on similarities between nearby others that you care for and more distant others, right? So this is a very different model than, say, like imagining yourself in another's shoes or the golden rule, right? It's a model where you start with nearby others and then extend based on principles of similarity. So yeah, so I've been thinking a lot about the contrast between those two different types of moral approaches. And so I guess I wanted to solicit your reaction to that as another possible kind of way into getting a little more nuance into how we think about training systems to be moral.
Mhm. Yeah, really interesting idea. The first thing I would say is I hope the DeGrouchy move gets a little bit in that direction, right? Because the idea of the DeGrouchy move is you're caring about what happens to the caregiver before you even have the cognitive wherewithal to represent selves at all, right? It's just as a matter, if you've interacted with really young infants, they don't know where their body begins and ends, right? Let alone represent themselves as these agents that have distinctive interests and desires. And they're going to be just as worried about, an apparent show of distress from the caregiver as they would be about sort of their own pain or distress, because the Grouchy says like the infant learns from this very coupled interaction, constant interaction with the caregiver, that their pleasures and pains have kind of immediate effect on them and vice versa, right? Also from the kind of constant coupling of when the infant cries or the infant appears happy, they get this immediate feedback from the caregiver. Now that's not, what you're going for exactly, this kind of selfless thing, but it's like a pre-self special case of this tight coupling between the early caregivers and the infant. Could we or should we scale that up to be a more selfless, kind of completely selfless, open regard for what happens to others? I mean, I'd want to hear a story about a particular inferential kind of learning trajectory here. The thing that I think that we learned from machine learning is that the systems are going to be more and more reliable the more data you give them, and they're going to be reliable in particular on situations that have a similar informational structure to the data they've seen already. And this kind of gives you kind of a natural reason to suspect that you're better at kind of putting yourself in other people's shoes. That is, to the degree to which you and the other person are similar or dissimilar as the sort of starting point, right? Because you have a lot more information about what it's like to be you or people like you than you have about what it's like to be other people or people who aren't like you. And the Grouchy and the other sentimentalists, they regard this, they don't talk about it in machine learning terms, but they regard that as the big challenge for the mature faculty of empathy that you're supposed to counter with moral education. And they have all these nice, kind of 19th century ideas about like reading literature about people who are very different from you and how that's going to give you the kind of information you need to see what it's like to be other types of people and help you make these kind of bridge inferences that I would describe in terms of sort of leaping across social space, flexibly when you need to. I guess I would need to hear another story about how even if you're very unlike the other person, you're able to recognize the sort of evidence or signs for what their situation is like
There's going
without.
to be a very different set of cognitive challenges and developmental trajectory. I mean, I'll send you my paper that I'm working on this. There's going to be a very different set of developmental challenges, right? So let's say that you're trying to imagine um, a 6-year-old girl, right? If you're starting from yourself and then empathizing, right? You have to do all this transformation, right? If you start for concern for your own 6-year-old daughter, then there's a lot less kind of transformation that has to be done. There's a lot less inferential challenge, right?
Mhm.
To go from one nearby other that you already care about to another similar, more distant other, right? You don't have to imagine yourself in the other person's shoes and then do all of this imaginative transformation of your own beliefs and desires. You just need to notice a similarity between how you would treat, say, this 6-year-old girl and this other 6-year-old girl is not relevantly different, so you should treat her the same, right? I mean, there are other challenges
So it's like
that you have.
transforming the situation as opposed to transforming your own uh, place in the
It's
situation.
closer to imagining uh, your daughter in the other 6-year-old girl's shoes than it is to imagining yourself in the other
Uh-huh.
6-year-old shoes and then assuming you care for your daughter instead of assuming that you care for yourself.
Uh-huh.
Right.
Yeah,
So I'm
that
yeah,
could be a really interesting supplement, and maybe the two types of approach should be developed together to see which one is more promising.
yeah, I think it's an interesting complementary type of approach that's underappreciated. It has a very different set of cognitive challenges and advantages.
Yeah, I don't see any reason why the kind of transformation you're talking about would be representationally more difficult than the kind I was talking about. So
Right. I'll
why
send
not?
you my paper on this.
Yeah, sure, thanks.
I have so many questions. So the first question would be, why are you so sure that the reliability problem is getting better? Because I'm always sort of astonished that people are so easily in the situation trusting the outputs of large language models in several domains, even though we know they are not reliable. First question. Second question is, if you succeed with this training, the system to be empathetic, that would be only one way. So you're not imagining that they also send social cues which will sort of enable us to pay back and think about them. So it's a one-way relation. And last question is, don't you think that in the end, maybe deep neural networks will not be the only architecture we are using, and we rather go for hybrid systems where we have some symbolic AI integrated in neural networks?
I'll do 2, 3, 1 if I can remember all the questions. 2 is easy. I just haven't thought about it. Maybe you could make me say some things about it, but I haven't thought about it.
Yeah.
Sure, if you have some ideas, let's talk. The third one, what was the third question?
In the end, it's hybrid systems
Oh
and
yeah, no,
not
I'm
only.
by default, I'm really pessimistic about hybrid systems just because we've tried them forever and they've never worked, to my mind, better than a pure bottom-up system. But I mean, that's kind of a flat-footed response. The nimbler response is to say the stuff I am looking at a lot now is these models that have so-called kind of inner speech or private dialogue, chain of thought, tree of thought type architectures like GPT-o1 is of this sort. And I think it's a philosophically very interesting question whether those are hybrid systems in the sense that people might want. I think they're totally empiricist friendly, top to bottom, because they learn to use. Sorry for people who aren't familiar with what I'm talking about. Like, oh, so one of the what O1 does, there's this idea in old Vygotskian tradition, right, that in development, many people, not all maybe, but most people learn to simulate their own voice in their heads and get a kind of inner monologue, right? Which is a very important faculty for maybe a lot of normative decision making and metacognition and so on. And researchers have recently been trying to get these models to engage in this kind of self-dialogue, sometimes implicitly and sometimes explicitly on the Vygotskian self-talk model as a way to bootstrap their performance to greater degrees of coherence and reliability, specifically on like planning and problem-solving tasks. And I think that's the main reason you see a big performance jump in O1 over previous versions of GPT, is that that's exactly what it does. Unfortunately, they keep the self-dialogue private, and they seems like they're never going to share it with us. But there are other models in the background where you can sort of see how this works. They say it's better from a safety perspective for what it's worth, because they say, don't worry, we know what it's thinking. And we can read the self-dialogues and make sure it's not planning to kill you. When it reasons with itself. But just as a matter of empirical fact, this does make the performance a lot better on math Olympiad problems and programming problems and multi-step planning problems, even things like counting that you would have thought LLMs are particularly bad at without more classical innate hybrid knowledge, right? And I've been championing this stuff and saying like, look, empiricism is still winning. And then some people push back and say, no, they just became hybrid systems. Now those are the classical symbols. And I'm like, no. I think this is an interesting debate to be had. And it's another workshop I want to have. And I think where part of the debate is going to come apart is, even though the language that's self-produced by the model in its inner speech is in natural language, and natural language is going to have a lot of the properties that mentalese or language of thought or whatever was supposed to have. They're not functioning like classical symbols, right? If you follow all the old constituency debate about, between classicists like Fodor and Polishin and Smolensky, it's better to say that these systems are thinking with language rather than in language, right? They're producing this language and then they're attending to the language, but the language is not itself like a constituent of a classical symbol in its internal computations. The internal computations are still continuously differentiable activation space computations. So that's the reason I think it's thoroughly empiricist, if that made sense to anybody. If not, I can explain more. The first question, I just didn't understand. You can try again, but maybe somebody else.
Yeah, so I think you would agree with me that outputs of large language models have limitations with reliability. And of course, each new model is trying to get more reliable.
Yeah,
and
they do.
as
They do get more reliable.
Yeah, but they will. I have the impression, maybe I'm totally misled, but it is a feature of deep neural networks that they have limitations with reliability. It's just a question how big the limitations are, not whether there is a limitation.
I mean, the question for me is about the type of limitations and whether there's some in principle ones we can already prognosticate, because people have limitations too. I mean, people are unreliable all the time. And they get better with training, and they share all kinds of the types of mistakes they make with the deep neural networks and so on. I mean, this is one of my long-term shticks, is that anytime somebody points out a problem with deep neural network performance, you just go and look at the human literature, and 9 times out of 10, you'll find that humans make exactly the same problem by and large. I do think the question is there an in principle reliability limitation that it looks like more of the same type of architecture and training can't overcome? And I'm not predicting hitting a wall yet. I continue to see better gains, especially critically. I mean, the argument of the book is that we're going to get better reliability, not just as a matter of more scaling of data and training and computation, but through architectural innovation that is empiricist in flavor, which is what, again, I think O1 has done exactly, is more architectural innovation that's empiricist in character.
I'm still skeptical, but we will see what the future brings.
Yeah.
Thank you.
Right. Well, thanks a lot. I really enjoyed the talk. Very interesting. So I'm interested in sort of relating your talk back to Eric's talk yesterday. And I have sort of a two-part question. The first would be, would you think of these types of AI agents that are empathizing as being sentient and or slash conscious? If yes, then do you think that they, as Eric thinks, should be treated with moral consideration? And if they're not conscious, but they do have the empathetic capabilities, would they nevertheless be perhaps appropriate objects of sort of moral concern? I mean, relating it a little bit to point 5 here on next steps, I would assume that those AI agents, social interacting with each other, would treat each other with some degree of concern, and given that the capacities they're learning are supposed to lead them to treat moral agents well. So how do you think about the sort of the relation between your talk and Eric's talk, basically?
Yeah, just to riff for fun on the last part, did you see the social simulation where they did in The Sims, and they gave each of the little sim a large language model agent driven, and they like organized a Valentine's Day party spontaneously, and were like giving each other gifts and inviting each other, and yeah, so I mean that stuff's already happening, and there's a number of other social simulations for more like businessy purposes, but I thought that one was particularly interesting. As for consciousness and moral worth, I thought like the only thing everybody agreed on was we weren't going to talk about consciousness because it's too hard. For that question, you know, first you got to tell me what you think consciousness is, and then I'll tell you. I don't really have a horse in that race. I never really have. I punt on it completely in the book by saying, you know, here's 7 different popular notions of consciousness. According to some, these systems are already conscious and have been for a while, and according to others, it looks like they probably never will be. You tell me which one is morally important. I don't really know. All I talk about in the book and in this work is sort of better and better modeling of empathy. I think probably some sort of really basic affective structure is morally relevant, and you could simulate or model a lot of the higher stuff on top of that without ever building in the real affect. I'm not somebody who thinks it's impossible to do that in Silicon, but my point would only be you could model exhibiting affect and responding appropriately to affect, I think, without doing the really low level modeling under that. So you could probably get pretty far with making these systems behave in an empathetically virtuous way without actually giving them moral worth. So maybe that's an interesting wrinkle between a couple of the other presentations here. I don't know. But I don't want to talk about consciousness until you tell me what consciousness is.
Yeah, well, I mean that's why I asked the question at the very end. Like, supposing that they're not conscious in some sense, so could they still, given their empathetic capabilities, be sort of worthy of more consideration? I mean, you could imagine such a view that you leave it open as, okay, we don't know exactly what consciousness is, but they are having a very significant sort of moral capability, and according to some theories of sort of moral status, that's what grounds moral status, like being able to be a moral agent of some sort. Yeah. I
mean, I tend to have I do worry it is sort of a welcome to the jungle type situation where there's just no right answer according to our previous theoretical frameworks, and we've got to just decide what we want to do. But I don't have really well thought out work on that particular question.
Before we all go, I wanted to remind everyone who didn't speak today or that was in the audience today. We do have an open call for abstracts to complete the anthology that these talks will be going towards. So we'll be putting that together over the next half of this semester. Thank you all for being here. Thank you all. Thank you to our panelists for giving their talks.
Yeah, thank you for the attendees and everybody. I know you guys are all busy, so thank you so much.
Thanks so much for organizing it, Syed and David. It was great fun and learning experience.
A lot of fun. Thank you.